So before we get started, how many of you are already working in IoT? 1, 2, 3, 4. Yes, I know her. 5. That's awesome. So we're going to take a quick look at the IoT landscape, what the Edge is about. The Edge kind of sounds nice and matrixy. Frameworks and some future work. So as she mentioned, we're in the Industry 4.0 age. It's all about the digital and physical worlds coming together, opening up new possibilities and whole new value paradigms, security issues, and a lot of new capabilities to make our lives better and maybe worse too. So that's up to us. But that's Industry 4.0 for you. Now, how many of you can read this? My eyes can't. But given that it is Industry 4.0, given the amount of potential that it can unlock, are we surprised that there's so many players in this space? Just about every and any company and a whole slew of new companies are in this space. And there are 3 bars pretty much here. The top level bar that maybe we can kind of read talks about application verticals. This kind of comes from your use cases, whether it's like an Alexa enabled application, whether it's industry or factory or cars. So it's talking about those verticals, and we'll take a little deeper look in a minute. Then it's talking also about platforms right here in the middle. These enable things in this IoT space. It could be payment, it could be voice-enabled systems, it could be security, you name it, okay? And then right down at the bottom is about infrastructure. Some of these capabilities are enabled by your cloud, some with different kinds of hardware, some very low price point ones, some more expensive ones, and even virtualization plays a role here. So the lowest level is about that infrastructure that's making your IoT possible, including 5G, all kinds of connectivity issues. So this eye chart you can definitely deep dive into with, the slide deck later. But just about everybody and anybody is in there. It kind of looks a little washed out here, but never mind. So what kind of use cases do we have here? We have augmented reality. It's not just that Pokemon Go kind of guy who's, hopping around in a fountain on the grass and you go catch. That's the only time my son decided to walk with parent objects, okay? So I need to go there, and all the Pokemons are in that park and that somewhere. Okay, we'll go with you. Thank you, Pokemon. So another thing that's very useful is also for training doctors and even helping patients in remote locations. That's where, new and different uses of augmented reality can come in, okay? Like somebody far, far away can look at something and say, that blood vessel over there, that's where I see something like a tumor or whatever. Supply chain. Somebody's driving down the highway and says, gas prices are $4 a gallon. Hey, how about I save a little money here? Why don't I turn off that refrigeration unit? The vaccine might get spoiled or the milk might get spoiled, and this is sort of the things that we can kind of track. What was that, thermometer temperature on highway 280, type of thing. So factory automation, retail, just name it, remote monitoring and management. How many of us want to be, going down some canyons and mountains to check on some power line there? It's risky, it's remote, and it's nice to have some drone flying out there checking on those things, and there are applications like that today. Windmills, you're not talking about one windmill facing the wind to harness the most energy, but it's a collective. You might have to move one this way and another way so that collectively they harvest more energy. So it's still IoT, but it's controlling at a slightly higher level. So what about transportation? And it's not just the autonomous car. That is coming, but it's still a little ways off. But even before that, you have insurance vendors who say, put my little app on your phone or in your car, and then the car's onboard diagnostics will, pump some information to my little app on your phone, etc., and I can monitor how you drive. Are you speeding? Are you doing a lot of hard brakes because you're this aggressive driver and the red light comes, so they want to track that, and then maybe they reward you with a lower premium, maybe they ding you, maybe they take away the license, and maybe it's good for us, and whatever, there is a big brother type of thing. So there are a bunch of different applications in transportation, even before autonomous driving. Smart city is one of them. Where are all those little blocks in your arteries of these roads? Should there be somewhere where we put a speed bump? Because, it looks like too many people are doing hard brakes there, or they're stuck there, they're not moving, so maybe we need to do something out there. So from use cases, let's just take a look at autonomous driving. No, let's look at insurance, smart city, my driving. And why did we even think of this application? I had just come from Intel working on big data, and BMW, we had a partnership. They wanted to process a lot of data to improve their autonomous driving platform. But liking cars, liking not to drive, liking, just to look out of the window, and then here's my colleague too who likes cars and likes to drive. So the two different kind of mindsets. We said, let's try and do this as an IoT application and learn something from it. And as open source engineers, one of the things that motivates me is to have hands-on experience with an IoT application so that I can build features on the platform that are useful, okay? Let's pretend like I'm a cloud developer. If I've never used a cloud, how do I know what feature is the most important? Or which one is not just that shiny, sparkly, Christmas tree ornament, but something that's really essential, like pouring water for that Christmas tree, okay? So we said, let's get an onboard diagnostic unit. That's a little thing on the top, the blue one. That's about $15, from Amazon or wherever. A GPS sensor. And then let's connect it up to our car. So you need a little more stuff over there. We said, we didn't want to use a phone. That's like $100. Can I make everything come together for less than $100 was the approach. So we got a little Raspberry Pi. What did we need to do? We needed to sense, gather the data from the sensors, do something with it. And this is where something like a profile comes in. Is this a heavy vehicle? Is this a little car? Because that then tells you what kind of acceleration speeds are considered, hard, brake, hard acceleration, things like that. And you don't want somebody to go over there and poke and change that profile. Like imagine a heavy truck saying I'm a lightweight vehicle, then those readings change. So you have some kind of data that's on the application that should be tamper-proof. So all these kind of notions, these problems started presenting themselves to us, because when you're designing an application, even though it's a toy one, even though it's like a science project, it brings out these issues, which then helps you when you're developing an open source product on what to focus. And some of the main things we comprehended was like, hey, when you're in a driving situation, are you really going to be able to communicate up to a cloud? No, you might not want to pay for that connectivity unless it's an autonomous car type of thing. And if you're talking a Waymo vehicle, you might have 2 such internet connections for resiliency. But just for that insurance app, you pay whatever money, you don't want to spend more money on them by giving them full-time network access. Further, what if you're in those canyons in Arizona? What if you're in a tunnel? What if you're in a city where there's not adequate bandwidth for all that traffic that's flowing through? So you need some processing locally. So you're going to have intermittent network connectivity. That's good still. Maybe only after you come to the garage. So that might be a sort of thought process when you design your application, that you push your data when you have the connectivity. Otherwise, keep it local. Keep only what's important local. Then there's contextual information. When do I consider somebody speeding? It depends where you're driving. If you're on an inner city road, you can't do 60 miles an hour. Maybe you're on the highway. That's where you could do it. Maybe you can even do 75 depending on the rest of the traffic. So sometimes you have to gather the data and then do some analytics afterwards based on where you were, based on those GPS coordinates, what that contextual information is to kind of determine what kind of events you had. And definitely, we already mentioned storage. And in this case, you might just be happy with the file system on this little Raspberry Pi to meet your needs. So with that, we come to the edge. Edge is where the action is. Edge is where the data is coming, the source of the data. You want to be able to process a lot of your data at the edge. So the early applications of IoT were like, here's my watch, it's transmitting everything to the cloud, and then from the cloud, you're reading it on your phone. But real IoT, for real big problems, whether you're looking at surveillance data, whether you're looking at this little windmill of yours and trying to tilt it, it happens at the edge, where those windmills are and where you have maybe network bandwidth limitations, both for cost, both for capacity, and where you have to have low latency responses. And that comes us to this point, the architecture. You'll have your devices right there embedded in your environment, a whole slew of them. They might be talking different protocols, it could be Zigbee, it could be Bluetooth, it could be Coab, name it. Then you have some edges close to them. Let's say you're talking about a factory automation. You might have one per floor, maybe one for the whole building, depending upon the number of sensors. Then you have data that's aggregated there, maybe some more higher level analytics, like for a whole wind farm type of thing, that going up into a cloud data center. And you heard Frida's talk a little while back where we were talking about federated analytics. That's something else, like where you have the edge data, new ones, important anomalous ones going up into the cloud so you can do some kind of distributed learning and then model distribution. Now these arrows are supposed to show you the distance, okay? The shorter arrow means that edge is closer to those devices. The longer arrow is supposed to be further away cloud. So given that, we come to frameworks. So let's just take a little deeper look at what that edge node is, okay? You have your actual application, and I broke it down into north, core, and south. The south is the one that really talks to all those heterogeneous devices. The core is where you might do some analytics, some pattern matching, some kind of alarming, name it. I mean, it's up to you. The north is where you might pump out some data to a public cloud or a private cloud or whatever your data center, where you might want to do some higher level analysis and action. But that's just talking about the application itself. What about the rest? Earlier on, we listened and we heard about, hey, don't we maybe have to do some patching of the operating system if we have a security vulnerability? Yes, indeed. IoT is about a vast network of devices. That means your space of attack, your attack surface is enormous. And there was a few years back a case where, little cameras were like part of a botnet attack, okay, bringing down a whole DNS server. So that attack surface, you have to shrink, protect, minimize, etc. And that's where you might have to apply these patches. So there's a whole parallel path, not just your edge application, your vertical related application, but about management of those nodes. Are those edge nodes sending you a heartbeat? Are they alive and well? I mean, can I assume that that nuclear power plant or that ATM machine is hale and hearty? How are the resources on it? Can I pump one more application on it? Or is the CPU already pegged at 80-90%? And that brings us to an open source project that deals explicitly with the edge. It's called EdgeX Foundry, and my team and I are working on this. And it provides you all these capabilities like alarms, logging for audit logs, a rules engine. It's written in Go. It's totally open source. We invite others to join this effort. It talks multiple device protocols. It deals with data persistence. It has ability to use MongoDB and Redis and even the file system. Like my little insurance app doesn't need anything groovy like a MongoDB or Redis. It doesn't need a distributed resilient database. It just needs that drives data, okay? Whether it's to know what I'm driving, how I'm driving, etc. And something nice about open source projects is you can look at the code. Did they actually hide personal information? Like when I'm talking smart city, I should not be sending the data about who the actual driver is and the actual vehicle ID. Only where this event happened. It's GPS coordinates and maybe the speeds. But for the insurance app, well, lo and behold, they'll collect everything off of you. So that's a little high level for you about EdgeX. And this morning, VMware, made generally available our software as a service application for something called VMware Pulse IoT Center. This part handles the management of the actual node. Were there any alerts and alarms? Is somebody looking at them? Is somebody addressing them? So this is that other parallel path beyond your application. And what else about things like campaigns? Did I want to push some new software out there? Maybe I have some new, if it's an insurance kind of app, if somebody's really driving slow or better or something, or maybe they get a discount, or maybe it's another kind of app about consumption of some pollutant or carbon footprint or whatever. So we can have different campaigns and different reward functions, and then actual devices themselves. Have I registered this device? This is a known expected device. Has it reported in? So this single pane of glass allows you to monitor your whole IoT edge infrastructure. With that, we're ready to talk about future work. And this is such a big area that we briefly mention everything. So security, as I mentioned, because this threat surface is so large, it's something very important. But something very critical about IoT, anything here new? No. We all know access control is important. We all know that security patching is important. We all know security linters are important as you write lines of code. Should you, hard code any password? Should you open all your ports? No, only some select ports, things that you put in your firewall rules. So nothing here is new. Audit logs are not new. Encrypted storage. So suppose somebody, cracks into your car. You don't want them to get everything off that, hard drive over there or your SSD over there. Secure boot, it's an old technology, but I think that technology's time has come now, because at the edge, you might want to reboot things often and check, is this free of malware? No different from our earlier talk, okay? Cornelia's earlier talk, where she's saying, hey, let's repave, okay? And this is repave at the hardware level, because even if you had introduced firmware related malware, you want to be able to detect it, kernel level stuff. Knock it off. Reboot, reinstall the old version, because that's malware free. So even if you get to one edge node, you don't really corrupt the whole system. So all those old, well-tried technologies come to the fore here. And that for me was one of the exciting things about IoT. After a career of about 20 plus years, everything comes together. Okay, I started way before it was sexy, but everything I've learned along the way helps this. With respect to EdgeX itself, we have a lot more to go, but we are already getting close to a June 1.0 release. Very proud of that. It has to have more tests, more documentation, some more performance-related re-architecting. A team member of mine is actually doing some of that. And more protocol support. As you have more devices, more protocol support. And we also want to make it more friendly to different vendors, because open source is all good and sound, but it also has to be viable economically. I mean, can we support other database solutions, etc. Finally, you want to be able to do your delta patching stable, okay? I mean, if only a few lines of your kernel are changing, you shouldn't have to send, 20 megabytes or whatever. I mean, just the bare minimum. And last but not least, can we also leverage other frameworks, especially orchestration frameworks, because you can think of your edge and say, hey, I just want this new containerized app to go land on all of them, all that I consider as my factory edge, or all that I consider as my healthcare edge. And you can do those with things like affinity groups and, aggregates and stuff like that. And a few references, and that brings us to the end. Thank you.